Okay, for 418, we're going to use the process that we developed in the lesson to factor these quadratic expressions. Okay, so we're going to start by drawing an area model, and on the side you're going to draw your diamond. So all of these diamond problems that we've been doing have been leading up to helping you factor quadratic expressions. And remember, you're going to put the x squared term in the bottom left corner. You're going to put the constant in the top right corner. If you were building this with tiles and you had to make a rectangle, you would start by putting an x squared tile here and then 12 red unit tiles right here, and then you'd have to figure out, how do I split up the 4 x tiles? And that's going to be your goal, is to figure out how to split those up. And it may not be that there's 4 x tiles, negative x tiles. It could be there's an amount here and an amount here, and when you combine them you get -4. So remember, we learned that the product of these diagonals is the same. So I know if I multiply x squared times -12, we're going to put that in the top of our diamond. I know that these two terms multiplied are also going to give me -12x squared. And I know that these are going to add up to -4x. So that's why -4x goes on the bottom, and that's why we noticed the pattern, that the diagonals, the product of the diagonals, are always the same. That's what helps you to figure out these missing terms. Okay, so we're looking for 2 terms that when we multiply them we get -12, but when we add them we get -4. Okay, so you know it's going to be something that has an x with it for each term. So what can I multiply to get -12, but when I add it I get a -4? So you're probably thinking about 6 and 2. Let's try it. Now for that to be a -12, one of those terms has to be negative. And to figure out which one should be negative, I have to say, okay, which one should be negative if when I'm adding them together I'm getting a -4? Well, -6 and +2 added together would give me -4, and -6x times +2x would give me a -12x squared. So there we go. We just used the diamond to figure out what tiles are going here and here. And we also used the pattern that we knew that this product would be the same as this product. Okay, so -6x, really doesn't matter which one I put the -6x in or which one 2x goes in. And then from there I'm just finding the length and width. I know x times x is x squared. I know x times -6 is -6x. I know x times 2 is 2x, and then I'm just going to check, is -6 times 2 -12? Yes. So x squared minus 4x minus 12 factors into x plus 2 times x minus 6. Okay, part B. Let's start by drawing an area model and then putting our diamond on the side. The diamond helps us to figure out those 2 terms that are here. This is 4x squared, this is 1, and we need to figure out, we know that this product is 4x squared, so we're going to have 2 terms that when you multiply them, you know when you multiply these 2, you're going to get the same thing as when you multiply these 2. That's why 4x squared goes on the top of your diamond. That's your product. And then you know that when you add these, you're going to get positive 4x. So that's why 4x goes on the bottom. Okay, so we're looking for two terms that when I multiply them, I get 4x squared. When I add them, I get 4x. Have you guessed it? 2x and 2x. 2x times 2x is 4x squared. 2x plus 2x is 4x. Now we're just going to get the length and the width of this model. So I know that's going to be 2x and 2x, although it could have been 4x and 1x, but I know that 2x times 1 is going to give me 2x. 2x times 1 is going to give me 2x, and 1 times 1 is going to give me 1. So this is going to factor into 2x plus 1 times 2x plus 1, which could be written as 2x plus 1 squared. Now it might be a little confusing because this is the sum, this is the product, and then we're using the words product and sum on our diamond. So you may want to just think about, what does product mean? Product means you're multiplying, sum means you're adding. This is the area as a sum, this is the area as a product. In the diamond, you're using the product and the sum to find your missing terms. Okay, part C. Put your diamond on the side. Okay, we know 2x squared is going to go here. We know negative 5 is going to go here. And when I multiply 2x squared times negative 5, I get negative 10x squared. I know when I multiply these, I'm going to get negative 10x squared, but I know that these two together, the tiles that are here and the tiles that are here, are going to sum to negative 9x. So I'm going to put negative 9x on the bottom of my diamond and figure out what two terms I can multiply to get negative 10x squared. But when I add them, I get negative 9x. Okay, well, you know it's not going to be 2 and 5 because that's not going to add up to 9. So it's got to be 10 and 1. 10x and 1x. Now when we multiply them, we're getting a negative 10. When we add them, we're getting a negative 9. So it must be that 10 is negative and 1 is positive. Negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. So this is negative 10x and positive 1x. So let's get the length and width of this area model. We know that 2x times x would give us 2x squared, but we've got to be careful about where we put the 2x. It can't go here because I can't multiply 2x times an integer, and we're looking for integers here, and get x. So the 2x has to go on the bottom and then 1x on the side. Okay, so x times what would give me x? That's got to be a 1. 2x times what would give me 10x, negative 10x? That's got to be a negative 5. Let's check and see. Does negative 5 times 1 give us negative 5? Yes. So this is going to factor into 2x plus 1 times x minus 5. It's okay if this is not perfect for you yet. That's why the homework circles back and you get practice with it pretty much every time you do a homework assignment. Okay, draw your area model, draw your diamond. 3x squared, if you were building this with tiles, 3x squared would go here. The negative 8 unit tiles would go here. And you know that this product is the same as this product. So then 3x squared times negative 8 is negative 24x squared. That product is going to be the same as this product, but these are going to sum to 10x. So 10x goes on the bottom. You're looking for two terms that when you multiply them, you get negative 24x squared. When you add them, you get positive 10x. So think about it. What can you multiply to get 24? 8 and 3, but 8 and 3 is not going to add up to 10, no matter which one is negative. What about 6 and 4? That's going to work. 6x and 4x, when you multiply them, you'll get 24. Oh, wait a second. That's not going to work, because you've got to make one of those negative, and if you make one of them negative, that's not going to add up to 10. Okay, so we also have 2 and 12. It's got to be 2 and 12. So 2x, or sorry, 2 and 12. So 2x and 12x, when I multiply them, I'm going to get 24, and I need to figure out which one should be negative so that when I add them, I get a positive 10. Well, that means the 2 is the one that has to be negative. Negative 2 times positive 12 is negative 24. Negative 2 plus 12 is positive 10. So let's put negative 2x here, 12x here, and let's get the length and width of this area model. We know 3x times x is going to give us 3x squared. Should we put 3x here or here? Well, that means you got to look at that row and that column. 3 goes into 12. 3 does not go into 2. So the factor, the term, is going to be the greatest common factor of that row or of that column. So 3x has to go here. It can't go here. 3x times x is 3x squared. 3x times 4 is 12x. X times negative 2 is negative 2x, and then negative 2 times 4 is negative 8. So this is going to factor into x plus 4 times 3x minus 2. Okay, there's some, actually, if you have the ebook open, which you should, there's some nice math notes on why this pattern works in this lesson. And this is, I keep forgetting to put this on the video, but this is lesson 4.1.2, and I recommend you have that open on your ebook so that you're looking at the problem. You're not just kind of writing an answer to a problem that you don't even know what the question is. Okay, when she was younger, Mary had to look up at a 68-degree angle to see into her father's eyes whenever she was standing 15 inches away. How high above the flat ground were her father's eyes if Mary's eyes were 32 inches above the ground? So this is nice. We're talking about inches. You don't have to do any changing of dimensions. Let's draw a picture. So here's Mary. And here is her father. So she's looking into his eyes, and she's 15 inches away. So draw the triangle. We know that this distance is 15 inches. And it said she had to look up at a 68-degree angle to see into her father's eyes. So then I know the angle of elevation is 68 degrees. And it also says that Mary's eyes were 32 inches above the ground. So this distance from here to here is 32 inches. So we know that if we're looking at a slope triangle, we know that the change in y over the change in x is the slope. So I'm going to write slope of And now we know that the tangent button on our calculator gives us that slope. It gives it to us as a decimal. It does not give us a fraction. It would not be a pretty fraction if we were to use the fraction. So the slope of, or the tangent of 68 degrees is equal to, let's put change in y over change in x here on the side. That's equal to the dimension that I'm looking for is y, the rise, over the run. Let's put a 1 under tangent of 68. And all we have to do is cross multiply here. So 1 times y is y. 15 times tangent 68 degrees is 37.12. Okay, why don't we just add, so that's this distance from his eyes to here. Let's add the 32 inches for Mary's height. So plus 32 is 69.12. So why don't we say about 69 inches, approximately 69 inches. Okay, for 4-20, we're going to complete this table for y equals x squared. So I'm going to pause the video and quickly sketch this on my paper. So if I know the equation is y equals x squared, I could use the table function of my calculator to get all of these values. However, I am concerned that you will not know where those values are coming from if we don't do at least some of these the long way. So we're just going to, actually this is not going to take very long if we do all of these the long way. So we're just going to plug in negative value of x. So negative 4 squared means negative 4 times negative 4, and it's different from, which is positive 16, that's different from negative 4 squared without the negative 4 being in parentheses. This would be, order of operations would tell me to do my exponent first and get 16 and just take the opposite of that. So that is a very common mistake that students make, and you need to be very careful about using a calculator, because if you type in negative 4 squared in your calculator, it doesn't know if you want negative 4 times negative 4, or if you just want the opposite of 4 squared. If you want negative 4 times negative 4, you've got to put negative 4 in parentheses. So be very careful with that. So this is going to be positive 16. Negative 3 times negative 3 is positive 9. Negative 2 times negative 2, positive 4. Negative 1 times negative 1, positive 1. Negative 1/2 times negative 1/2 is positive 1/4. 0 times 0 is 0. 1/2 times 1/2. 1 times 1. 2 times 2. 3 times 3. And 4 times 4. Okay, now it says to sketch the graph. So you do need some graph paper. Let's do a quick XY axis, and your highest Y value is positive 16. So you got to think about that as you are setting this up on a sheet of graph paper. If you've got a full sheet of graph paper, kind of do this towards the bottom so that you have plenty of room. Okay, and I really don't like to, I like to go with an interval of 1. So the x values range from negative 4 to 4, and the y values, my lowest y value is 0, my highest is 16. So let's just use an interval of 1. So this would be -1, -2, -3, -4. Let's just put a -1 here. And then this would be 1, 2, 3, 4. Okay, and then we've got a high value of 16. Okay, quadratics are a major focus this year, so I really want you to understand them and not just be going through the motions like everything. I want you to understand it. Don't just go through the motions with math. Make sense of it, even if it takes a little time. So let's just graph these points. We've got -4, +16. We also have +4, +16. We could actually start with 0, 0. Maybe let's start there. So we've got the point 0, 0. And you're noticing that these are symmetric. We've got -1/2, the value is 1/4, +1/2, the value is 1/4. So that's really close to the x-axis. I'll just put that right there. We've got -1, 1, +1, and 1. We've got both -2 and +2 have a value of 4. This input has one output. This input has one output. It happens to be the same output. But this is still a function because each input has exactly output. So let's do -2, 4, +2, 4. And then we've got -3 and +3 have an output of 9. And then we've got -4 and 4 have outputs of 16. Okay, this shape this U shape is called a parabola, and it is symmetric, and the line of symmetry is the x-axis. And it even has this in the book. The vertex is the maximum or minimum. Where's the vertex that you graphed? So our vertex is the point 0, 0. And it's a minimum. Oops, there you go. Okay, for 4-21, it says calculate the expected value. So if you look at this picture, we've got a 30-degree angle, and then the rest of that would be 330 degrees because the full circle is 360. So my expected value would be, let's just go ahead and draw this real quick. 30 degrees, whoops, I should have put that over here. 30 degrees. If you land on this part of the spinner, you get 9 points. If you land on the rest of the spinner, you get 4. So that's going to be 4 times the rest of the circle would be 330 degrees. So 330 out of 360 plus 9 points if I land on that part of the spinner, which is 30 out of 360. So I'm just going to put all of that in my calculator at once. And I got 4.4, let's round that off to 4.42. So it's not a fair game. If it were a fair game, that would have turned out to be 0. For part B, this is kind of funny. They have a circle, and the full circle has a value of 12. So basically, you're going to do 360 out of 360, which is 1, times 12. So 12 times 1 is 12. Not too many games like that. Okay, for 422, examine the triangles in the diagram at right. Are they similar? If you decide that they are, justify your conclusion using a flowchart and solve for x. So I'm going to pause the video and sketch that diagram. Okay, so taking us back to our chapter on similarity, we have parallel lines cut by two transversals. And remember, if you don't have a perfect picture, you can turn it into a better picture where the lines are extended. These four angles here are going to match these four angles here because the lines are parallel. So I know that this angle, if I were to slide this down to this intersection, it would land right here. And I know these two angles are vertical angles, so they're equal. So this angle is equal to this angle. And then you've got vertical angles right here. You could do that same process that I did here with these two angles, but it's not necessary because if you have two angles in one triangle congruent to two angles in another triangle, they are similar by angle, angle. So let's go ahead and write this statement. We would have triangle EHZ similar to triangle E corresponds to G. So E is first, G has to go first. H corresponds to F. H is second, F would have to go second, and then Z corresponds to Z. So from that statement, I'm going to write a proportion. So EH is to GF as HZ is to FZ as ZE is to ZG. If you take the time to do this, you will have it set up correctly and probably get the whole thing correct. If you just guess on which sides correspond, sometimes you'll get it right. I'm not saying you have to do this every time, but it's good to know this in case it's a test question. I would take the time, make sure it's set up correctly. Okay, so EH, I don't know. GF, I don't know. So we're just not even going to worry about that. Ratio, HZ is 24. FZ is x plus 2. Looks kind of like the ones that we've seen on Con. Oops. Okay, maybe that's not a good idea. Let's leave that off. ZE is 20. ZG is x. So we have 24 times x is equal to 20 times x plus 2. Let's go ahead and distribute. That's going to give me 20x plus 40 equals 24x. We've got x's on both sides. We need to get all of our x's together on one side. Let's get rid of the smaller one by subtracting 20x from each side. So 4x equals 40. And then we're going to divide both sides by 4. So x is going to be 10. Okay, last question. Larry saw Javon's incomplete Venn diagram at right and he wants to finish it. However, he does not know the condition that each circle represents. Determine a possible label for each circle and place two more shapes in the diagram. So let's quickly sketch what he has. He has an equilateral triangle in this circle, and he has an equilateral quadrilateral in the intersection. So I'm thinking that this circle must be equilateral because both of these are equilateral, and this is probably quadrilaterals. It just says determine a possible label, so we could go with that. So let's put equilateral and quadrilateral. Remember, quadrilateral means it has 4 sides. So we're just going to put another quadrilateral that is not equilateral here in this area. So a rectangle would work. Rectangle has opposite sides equal, but it's not equilateral. And then I'm just going to put another equilateral polygon on this, in this section right here. So I'm going to put maybe an equilateral pentagon. Do you remember that? That was from, I think, the very first day of school.